Welcome to Review and Preview Problems 1043 to 1049 in the CCG book. 1043 says, if line segment QS is the diameter and PO is a chord of the circle below, find the measure of the geometric parts listed below. So looking at my circle, they gave me 63 degrees. I see that this angle is connected to the outside of my circle, so I know that arc PS has to be double that. So 63 times 2 would tell me that arc PS is 126 degrees. So depending upon how you see things, you may see differently what someone else sees. I then also know that PQS touches at the same chord. So if I look for angle PQN, it should be equivalent to 63 degrees. If I know that arc PS is 160 degrees and QS is the diameter of my circle, this is a semicircle, so 180 minus 126 would tell me that arc QP is 54 degrees. So we know QP is 54 degrees. I can then determine this arc length right here, because if I take 180 minus 80, I know that this arc length should be 100 degrees, which would make QSO half of 100. So angle QSO would equal 50 degrees. I know that QPO is connected to the same points on the circle Q and O, so it would have to also be 50 degrees. And then if we look at the measure of angle O and S, we could figure that out by doing 180. 180 minus 50 minus 63 would tell us that that is in fact 67 degrees. 10-44 says for each triangle below, solve for the given variables. So in triangle A, I notice that I am looking for an angle, am given an angle, and then given two sides opposite those. So the law of sines, we can solve for a missing angle by setting up a proportion. So if we do the sine of 110, put that over 16, we can set that equal to the sine of x over 9. Cross multiply. So 9 times the sine of 110 equals 16 times the sine of x divided by 16. We're looking for the angles, so remember we need to use the inverse sign. Tells us that x is approximately 31.9 degrees. We then can figure out our missing angle by taking 180 and subtracting 31.9 and 110. So our missing angle is about 38.1. We can then set up another ratio and say the sine of 38.1 over y is equal to the sine of 110 over 16. So we have cross multiply 16 sine 38.1 equals y sine 110 divided by sine of 110. Type this into your calculator and we get y is approximately 10.5 inches. Looking at letter B, I'm looking at an isosceles triangle, so I know that my opposite side is 8. I can find my angles inside because they should be the same. So 180 minus 27 gives me 153 divided by 2. Tells me that my base angles are 76.5. I then can set up a proportion. The sine of 76.5 over 8 is equal to the sine of 27 over x. Multiply x times the sine of 76.5 is equal to 8 times the sine of 27. Divide by the sine of 76.5. And we get x is approximately 3.7 m. Looking at our right triangle. So we are working with a right triangle. We are missing an angle. Opposite that angle is 9. Adjacent to that angle is 13. So the tangent of x is equal to 9 over 13. Again, we want to use the inverse tangent button, so the -1 on your calculators. Type that in, and we get x is approximately 34.7 degrees. We then can use our right triangle trig to find our missing piece, a squared plus b, the Pythagorean theorem. 9 squared plus 13 squared equals c squared. 9 squared is 81, plus 13 squared is 169. When we add those together and take the square root, we get 250, which is approximately 15.8 feet. 10-45 says the spinner below is designed so that if you randomly spin the spinner and land in the shaded sector, you win $1 million. Unfortunately, if you land in the unshaded sector, you win nothing. Assume that point C is the center of the spinner. If the measure of angle ACB is 90 degrees, how many times would you have to spin a reasonably expected to land in the shaded sector? How did you get your answer? Well, if we have a circle that is 360 degrees and divide that by 90, we would reasonably need to spin 4 times. What if the measure of ACB was 1 degrees? Well, we would take 360, divide that by 1, and we would reasonably need to spin 360 times. Suppose the probability of winning $1 million is 1/5 for each spin. What must the measure of angle ACB equal? Show how you get your answer. Well, if it's 1/5, we can take 360, divide that by 5, and get our spinner needs to be approximately, or the angle needs to be about 72 degrees. Calculate the total surface area and volume of the prism below. Assume that the base is a regular pentagon. So if we are looking at our pentagon, we have 5 sides. So we have 5 rectangles that are 12 by 6. So if we multiply 12 by 6 times 5, the surface area for our rectangles would be 360 feet. To find the surface area of our base, we know that half of this is 3. If we take 360, divide that by 5, we get 72. If we divide that by 2, we know our smaller angle right here is 36 degrees. In order to find our height, the tangent of 36 degrees is equal to our opposite side over our height that we're looking for. Multiply both sides by x, divide by the tangent of 36. So x equals approximately 4.13. To find the area of our triangle, we do base times height divided by 2, so 4.13 times 6 divided by 2 gives us about 12.39 for the area of one triangle. We need to multiply that by 5 because we're working with a pentagon. So the area of our base is 61.94 feet squared. We have 2 of those for our surface area. So we need to take 360, add 61.94 times 2, which gives us 483.88 feet squared. For our volume, we're going to take the area of our base, multiply that times our height, which is 12 feet. So 61.94 times 12 gives us a volume of 743.28 cubic feet of our regular pentagonal prism. 10-47, quadrilateral ABCD is graphed so that A is at 3, 2, B is at 1, 6, C is at 5, 8, and D is at 7, 4. Graph ABCD on the graph paper. What shape is ABCD? Justify your answer. So it is a square. We could justify our answer a couple of different ways, but our slopes are opposite reciprocals. So we know they form 90-degree angles. And then we could also say, based on our slopes, that our sides are parallel. ABCD is rotated 180 degrees about the origin to form A prime, B prime, C prime, D prime. Then ABCD is reflected across the x-axis to form A double prime, A, B double prime, C double prime, D double prime. So if we reflect that, you could use the Desmos tool. You would see that C prime would be located at the ordered pair -5, -8. when it was rotated about the origin. D prime, after reflecting it over the x-axis, would be at the ordered pair negative 7, 4. 10-48. Polly has a pentagon with angle measures 3x minus 26. So we have a pentagon, 5-sided figure, 3x minus 26, 2x plus 70, 5x minus 10, 3x, and 2x plus 56. Find the probability that if one vertex is selected at random, then the measure of its angle is more than or equal to 90 degrees. So we can solve by x in this, or what x equals, by using our interior angle sum. So I know there are 3 triangles within this, so the sum of a pentagon is 540 degrees. When we combined all of our like terms, 3x plus 2x is 5, 10, 13, 15 x's, negative 20, so 56 minus 26 plus 70 minus 10 gives us plus 90. 540 minus 90 gives us 450. Divided by 15 tells us that x is equal to 30 degrees. So when we plug 30 degrees in for each of those x's, our smallest measure is 64 degrees, followed by 90 degrees, 116 degrees, 130 degrees, and 140 degrees. So remember, we found those by replacing our x's in our angles. So the probability would be 4 out of 5 chance of getting an angle larger than 90 degrees or equal to. 10-49, which graph below represents y is greater than negative 1/2 x plus 1. Looking at my inequality sign, it is a greater than symbol, so it needs to be dotted. So choice A and choice B are out. When we pick a test point 0, 0 and plug it in, is 0 greater than 1 is a false statement. So we do not want to shade over 0, 0. We want to shade the opposite side. So C would be the correct graph of this inequality.